Sea level rise is one of the most serious consequences of the human-induced climate crisis. The water rise is from heat expansion of the oceans, melting polar caps, vanishing glaciers, and the loss of fresh water. Satellites are an essential tool to monitor the changes and help climate modelers prepare us for the future. NOAA GOES-T satellite in geosynchronous orbit is a recent addition of the next generation of satellites. It is the Western Hemisphere's most sophisticated weather observing and environmental monitoring system, covering over half the globe. Along with the decades-long Sentinel series of satellites. Sentinel-6, a collaboration of European and US space agencies and climate monitoring institutes, is continuing the mission of uninterrupted, sophisticated data gathering for climate scientists and modelers.
Well, the main instruments on board include a dual-frequency radar altimeter. This is the primary instrument of the mission, and that's the one that's measuring sea surface height, significant wave height, and wind speed over the ocean. And from those measurements, we can actually have the superb measurements that we expect of sea level rise, but also the waves. The significant wave height, which is the top 1/3 of the waves, if you were to look at them in time, so the biggest waves that you would see. This is important for marine operations, and the altimeters provide perhaps some of the best data sets that we have today over the global ocean. We have plenty of buoys in the ocean that measure waves, but they're often in the coastal zone, and it's only when you go to the altimetry that you can really have this global coverage.
We all know sea level is rising. And how do we know that? Because we measured this since the 90s from space through a series of satellites. It started with Topex Poseidon, which was a French-American satellite, followed by the JASON 1, 2, and 3 series, which was also a French-American satellite. And Sentinel-6, as you said, also called JASON CS, stands for Continuity of Service, is meant to go in orbit to follow JASON 3 to continue the record of the sea level since about 30 years. And we want to continue that record for another 5 years and demonstrate and quantify the sea level rise we have been observing since the 90s, in average about 3.2 millimeters per year, even though the scientists tells us in the last year this has been accelerating, in particular due to the acceleration in melting of ice. So over the last years, it's above 4 millimeters every year we record in the sea level.
We talk about the impact of melting snow and ice surfaces in terms of what's known as the albedo effect. When snow is dry, it's very reflective, and of course that helps to reflect sunlight back out into space, and the consequence is we can reduce the amount of melting this way. However, as ice and snow melt, the albedo and the reflectivity becomes lower, and this has the effect of absorbing more of the solar energy. This contributes to further warming and further melting. And so it's a runaway progressive effect caused by the reduction in the albedo.
Satellites are a major source of global, timely long-term data sets, which is in particular very important for climate, because we need to have long-term data series to actually understand how the climate is changing over decades, for example, and to also understand what the trend of these changes are going to be. So we are using a large variety of different data sets. We're mainly concentrating on the European Space Agency's data sets, and there's a mixture between data sets that come from, a heritage mission, like, for instance, Envisat and ERS, because we're looking also back, of course, in terms of climate. But we're also using data that are coming in right now, for example, from the Sentinels missions that are running under the Copernicus program that we are running together or collaborating with the European Union and EUMETSAT together. But we're also using actually quite new technology and satellites that address scientific questions that haven't been addressed before. So it's a mixture of different data sources that we are trying to combine in these climate data records.
What we do is we also work with partner agencies worldwide. So we exchange data over climate. We do work on calibration activities. We support activities linked to, for example, ice loss volume monitoring, and we have done that with the US partners over INBE campaign over the Arctic region.
To calibrate the satellites in orbit, scientists on the ground take measurements in situ all around the globe, from the Antarctic to the Arctic and glaciers around the world. They then compare results and validate the satellite data.
And we're producing climate data records, so long-term data records of climate-relevant indicators, let's say. One of them you see behind me. We are also producing climate data records for glaciers, in particular the extent of the glacier, the velocity, but also the elevation.
The ice loss in the Alps is comparably strong. So we have similar strong mass loss, I think, in the Andes of Peru and Bolivia, but also in Patagonia. They have similar rates. But the most difficult thing or problematic thing is that this ice loss in the Alps is still increasing. So now I think for something like 35 years, we see higher and higher loss. And this takes place despite the fact that the region where ice can melt, the so-called ablation region, is shrinking. And this is a very strong signal for accelerated climate change and an increased forcing, which means that temperatures have to increase and push the snow line higher and higher, so that more areas are exposed to melt.
Those projections tell us what glaciers will look like. What they will look like very much depends on what we, human beings, will do next in terms of greenhouse gas emissions. So if we manage to mitigate climate change very much, we will have glaciers that will still shrink, but will shrink a lot less than if we don't manage to get hold of this climate crisis that is literally unfolding. So in the worst case, where really our emissions will continue to go unabated until the end of the century, well, this place where we're standing is going to be ice-free for sure. But even the highest elevation that we see here, they'll most likely be ice-free as well. On the contrary, if we now really manage to put effort in abating emissions, we will be able to save, say, at least 40% of the ice. So half of this place is gone anyway, but still there will be something that we can look at and that we can show to our children and that our children can show to our grandchildren.
I think the recent record since Cryosat, one of our satellites, has been flying, has shown that there's quite some fluctuation in the amount of ice transferred from land to the ocean. However, we have seen that sea level rise has been accelerating over the last several years. One of the reasons is thought to be related to the increased melting of land glaciers. And a recent publication has shown that in fact the contribution of glaciers to sea level rise is increasing. And we've gone from a situation in the 1970s and 80s where it was contributing only a fraction of a millimeter a year to something closer to 1 millimeter a year. This is around 20–25% of the sea level rise signal globally. And so glaciers are obviously having an increasing contribution to sea level rise over the last 2 decades.
The European Space Agency is doing a lot in providing the evidence for a changing climate. If you think about the Earth observation program, for example, I think the majority of activities are really directly addressing this question. And it starts at the perceiving new satellite measurements. So, one of the core activities of the European Space Agency in the Earth observation program is, of course, to build satellites. And there's different flavors of these satellites that address, new technologies, new scientific questions, like, for instance, the Earth Explorers. But then there is the Sentinel missions that we are developing in collaboration with the European Union and with EUMETSAT, who provide, for example, continuity on many of these measurements, but also improve over coming decades, because we have a lot of experience in these measurements. And I think so, we're doing in ESA, I think something, it's almost like covering the entire food chain of providing climate relevant information. And I think this is quite an amazing fact, because we really follow through from the beginning of the measurement up to the point where we're actually talking to the people who put the policies in place. And I think that's a really good foundation that we're providing from the ESA's perspective.
So when you fly around the Earth at 400 kilometers, you have a very unique point of view that is at the same time a privilege and a curse. It is a privilege because, of course, not many people get to do it. Not many people get to fly in space and look down at the Earth. It is a curse because what you see is, at the same time, so beautiful and so fragile that it certainly breaks your heart. And it is what inspired me to start talking about what happened, what is happening on planet Earth, and about everything that we take for granted today. And as a matter of fact, that same feeling of helplessness and desire to do something, I felt in these last couple of days, talking to the scientists, talking to the explorers, and being myself part of the group on this glacier and looking with my eyes, touching with my hands, the same things that I felt from space. So if I had to summarize the feelings, which is always hard because feelings don't come in a linear way, they're always very mixed up. I feel a little bit of urgency. And because it's me, I also feel hope that people will listen and understand the urgency of what is happening and how fast we have to react before everything that we have will disappear.
Low-lying regions of the world, of course, are going to suffer the most from this kind of impact in terms of ice melt and sea level rise. Of course, countries like Bangladesh already suffering from the increased probability of storm surges as sea level rises. And coastal inundation is a problem for millions of people in Bangladesh. We also see it in more developed countries. We have a situation in Venice during seasons of the year where tidal range and storm surges combine with sea level rise to cause what's known as acqua alta. And there, the whole of the city of Venice is inundated by water on a regular basis during these periods of time. So I think the societal impact of coastal inundation and flooding can affect millions of people in the future. And so we need to monitor the effects of melting ice and sea level rise. we got the long-term data, and we got the long-term trend, and we now finally realize that you have the long-term trend, but you also have superimposed local variations. So some years it stops, and other years it goes very quick. So it's really a very dynamic system, and that just really means that we have to have a continuous monitoring from space.
I believe that there is an awareness that is growing, but is not enough yet. So water being probably one of the resources that we really need to check, and we are here because of that. Water has a cycle that we have interfered with. Ice turns into water, turns into atmospheric water, and it accelerates hurricanes, it accelerates flooding, it's all connected, and we have interfered with that cycle. So now we have to do something to take a step back. Well, one of the things that we can do is preservation without pollution. So little steps that everybody can do. Have a bottle of water and reuse it instead of continuing buying extra new bottles of water and polluting the earth with the plastic, and using extra water that we don't need. We can live on very little water. We are just not used to do it because we don't think about it, and we take it for granted. I believe that the perspective that I have comes from the awareness that on the space station we live on very limited resources. We have to recycle them, and we have to respect that awareness.
What we're doing in the Climate Office, and not just in the Climate Office, but in the European Space Agency Earth Observation Program at large, is, I think, 99% supporting the cause of understanding what our climate is doing, how our climate is changing, and that in turn can actually inform policymakers to take action of what needs to be done to either mitigate that effect, so basically, for example, limit emissions, or to adapt to things that we cannot change anymore. It's a very important physical evidence to give decision makers and policymakers a base to come up with plans of how we address this issue.
Ice is changing a lot, and ice is melting a lot. Whether it's a problem, of course, long term it's a problem because the sea level rise will go up. But it's also to some degree an opportunity for some of the Arctic countries that they can develop their countries. So it's climate change, monitor what is happening, make sure we can give a qualified statement, and especially the space is very important to give a qualified statement of what is really happening and not just some model prediction or some fancy outlook which could be way off. So I think we're the guys who give the hardcore facts. And as you say, I've been here for many years. I've seen the change on my own eyes, because before we even got involved with European Space Agency, we did a lot of airborne, a lot of mapping work. We mapped with the first satellites already in the very late 1970s as the very first users of satellite navigation, namely for mapping remote and distant areas. So it's been really amazing to see, and also amazing to see the changes, and the changes are big, no doubt about that.
And we're producing these data sets also for the benefit of addressing these international climate drivers, so that we actually know where we're standing at the moment in terms of the state of the climate and what actions need to be taken in the future in terms of policy and decision making and adaptation and mitigation actions, for example, in the future.
Because of the availability of information that we are constantly bombarded with, there is a general feeling that we can all be experts at everything and come up with our own opinion. I don't want to dismiss anybody's opinion, but I do want to listen to what experts and people who have devoted their lives to a certain study have to say. Now, it's a cycle. We have scientists who use their instruments to gather data, study those data, and come out with a theory. And once they come out with a theory and everybody agrees to it, then we should probably listen to that. And how do they get these instruments? How do they gather that data? Well, there is a whole community of people, technicians, engineers, astronauts, operators that work constantly, incessantly to create the instruments and to position them and to create the basis so that the data can be collected in the correct way.
The sea level will go up, no doubt about that. So people in Holland and the very low-lying areas, they should have good reasons to be concerned. So do we in Denmark. But again, right now it's only 10 centimeters, so we are talking 2,100. We talk anywhere between 30, 40 centimeter and a meter. Then it's a little bit more concerning. And again, that's where this long-term space mission, they will tell these people who make the modeling and the prediction in the future, if they made the modeling earlier, will it really fit what we see today? If you take all the data today, will it fit in 10 years? That's why you have the big value of these continuous data. And also the continuous measurements really of, do the satellites measure the right thing? Is the radar really measuring the surface, or is it measuring somewhere else on the ice? That's all the questions we are concerned with.
Most scientists agree we are past the point of no return. Now the focus is on trying to mitigate the most serious effects on the planet.
So it is a concern, of course, and eventually we should do something about it. And again, the space mission can tell you in the long run, if you change something in the CO2 with the political side, will it really matter? And for instance, the CO2, also in the Copernicus program and the ESA missions, you have CO2 missions, which are really useful to actually pinpoint who are the bad guys in this game, who is not cutting back eventually.
As a scientist, I think we can provide data, and the satellite data help us to do so. The issue with the glaciers and the shrinking glaciers is a global scale phenomenon where people are really concerned that in the future there is no more ice or much less ice. And what we can provide as scientists is solid data about how much ice there is, how the ice masses change, and maybe when you do some computer modeling, also how much ice there will be in the future. And over the past 20, 30 years, I think the reporting from us was more and more, yes, they are shrinking, and glaciers are shrinking globally, and they do it stronger and stronger. And we can repeat this information again and again and have it in IPCC reports and say, hey, there's a problem. But of course, in the end, it depends if this message is picked up and converted to action. And here is then very soon the place where the engagement of scientists end, because this is a political thing, and what we can do is provide the best data and the best uncertainty information we can get and say, really, we are sure about this and about this and about this, and not so sure about this. And then politicians have to decide on if they want to do something about it. And we hope that at some point this will happen.